It's either going to work or it's not. We're going to find out in a sec. All right, so unfortunately I got to type all those values in again. 82.9, 4, comma, 73.6, 6, comma, 65.7, 8, comma, 49. I missed something. 8, comma, 49. 10, comma, 53.3. 12, comma, 48.5. And 14, comma, 44.4. All right, so we got our values. All right, so it's not blacking out again, so that's good news. I'm going to roll it out. You could use the zoom in, zoom out feature if you want, but drag, roll your mouse until you can see all the points. That's really all we need. All right, something that shows all the points available. All right. So then what we're going to do is type in these different functions: linear, polynomial, and exponential. I didn't leave it to you to just figure it out on your own. You're just going to follow the steps. You're going to type in what you see. Now, in some cases, it's kind of annoying because you got to type in the letters A through H repeatedly, but it's still better than having to do a lot of this stuff by hand. So fit line, open parentheses, create a squiggly bracket, and then you're going to type in A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, G, comma, H. And then when you hit enter, it's going to plot that line, assuming that it wants to. All right, so let me do that again, because I must have missed something. Fit line, list of points, A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, G, comma, H. I think I might have hit an extra. Okay, now it's deleting.
So we're just typing in fit line and then
And then the list of values.
just put like colon or something? Or?
Just the squiggly brackets. I'm going to type it in exactly how it says it. No, this doesn't make sense. Select the function. I'll do it this way. Yeah, that happens. It just inserts the like what you're supposed to include, but what I'm running into the problem is why it's deleting it. A, B, C, D, E, F, G, H, A, B, C. Oh, I'm missing the D. But even still, that shouldn't matter. It, for whatever reason, is not working, and I am about to go.
Brackets in your own as well?
Yeah.
Why don't you try just without brackets? Maybe we'll just plug it in.
Yeah, if that's the case, then they changed how it worked overnight.
I was thinking like without brackets, maybe it will just come up.
Nah, you see? Yeah, you don't need the coordinates, you just tell it what it is. Do it that way, but that's not useful. let me just do a quick delete on this. Move this over a little bit. Delete that. Let me check my coordinates. Oh, that's why. Look at that. I make my own problems. I typed it in as 82,9 instead of 82.9. So it's not GeoGebra, it's not the college, it's just me. I didn't type it in correctly. So fit line, just double check I didn't do that anywhere else. Now it's gonna work. Ay, ay, ay. All right, well, that took longer than it should have, but it finally got there. And you can see, I mean, you'll know you're doing it right if it matches up with what I have on the handout or the PDF. Because I know this is right, so if this matches with that, then we're in good shape. All right, so then you're going to type in r squared. And we're going to do the same thing again. We're going to type in A through H. But then we're going to have it in, we're going to indicate to GeoGebra what the function is. All right, so all the points A through H, A, B, C, D, E, F, G, H. But then also, you see fit line has been designated as function F. By hitting enter, it's going to give us the r squared value. Provided I spell it correctly. Of 0.92. All right, so from the last unit, we learned that the r squared value tells us the strength of the relationship between the two variables. So 0.92 is pretty strong. I mean, it's very strong. It's almost perfect would be 0.95 or better, but this is very, very strong. All right, so it's a good relationship between the variables. Now you're looking at the variables relating time and temperature for a bun after it's been taken out of the oven. All right, so it's a bun that's cooling. So it would make sense that as time goes on, that the temperature would decrease until eventually it leveled off. I don't think it's going to be after 20 minutes 0 degrees Fahrenheit. All right, so that wouldn't make sense. Mathematically, it's saying it's a strong relationship, but I don't think it's going to last that way forever. Right? So what we do is we try some other functions, the fit poly. So this is where GeoGebra ends up being a good resource where the graphing calculator is not as good. See these little 3 dots? If you click on them, it gives you the option to duplicate. You can find special points. Special points would be like turning points or roots or things like that, but you could duplicate or you could delete. Obviously, we don't want to delete, but I do, in this case, I do want to duplicate because then I can edit and not have to type in the A through H again, all right? So then I can just change line to poly and then just make the adjustment because I want a degree 2 polynomial. That sounds really fancy, but that's just basically saying I want a parabola, all right? So fit poly degree 2. And it'll give me a parabola that would fit it. Now, this will allow me to give any kind of function. Now, if you've taken college algebra or trig, or even college algebra functions and models, or any kind of function-based course, you know that we can increase those powers as much as we want. It could be a 10th degree equations, x to the 10th power. Right? The more power it has, the more curvy the function is. Right? So at some point we could actually fit all the points through a curve, but will that curve make sense contextually? Maybe, maybe not. Now you see that this polynomial function is designated as g of x. So what I'm going to do is, you could type all this in again, or I could just duplicate and just change the f to a g. And now I could see that the r squared for the line was 0.92, but now for the polynomial, for the quadratic, it's 0.97. All right, so that's a better fit. So what I'm going to do is I'm going to turn off my line. See the little dot that's right next to each of these commands? You could turn it on or you could turn it off. If you turn it off, then the points disappear. All right, the points I want to have on, but the line, that's not my winner, so I don't want that. So I'm going to turn it off. So far, my polynomial is the winner. The winner is the function that's closest, that has an r² value closest to 1. All right, so now I'm going to look at exponential. So same stuff. I'm just going to do a duplicate on fit line and change the line to exp, and it'll give me the exponential model that fits. All right, and I'm going to do an r² on that. All right, so do a duplicate on my r². Now you can see exp is designated as h, so I'm going to change f to h. Now you can see that that's a 0.95. That's pretty good, but it's not as good as the g of x. All right, so mathematically, the g of x is the better one. So I'm going to turn off h of x and just go with the g of x. But this is how we investigate best fit models. All right, so imagine doing this on a calculator. You'd have to do it as separate steps and then be like, oh wait, what was that number? Let me write it down. Here we get it all in one shot. All right. So now that I decide that mathematically the best fit model is the polynomial, then I can go from there. The word's not drawback, but the one thing you have to be mindful of is context, because that's the thing. Like, as we move forward in this course, we're going to be marrying the numbers with context more and more, to the point where sometimes you'll dismiss something that's mathematically more appropriate for something that's more realistic. So right now we're just learning how to use GeoGebra, but later on we're going to be talking about the context. And now, if you think about it, you take something out of the oven, like a pie. You take it out to cool. It starts cooling. Eventually it levels off to room temperature. Does it then start heating up again on its own? No, probably not. Right? So does this make sense as something that would decrease in temperature and then start increasing in temperature just because? No, I don't think so, but we're just focused on the math behind it now. In fact, you may look at the exponential as being more appropriate. However, this doesn't even really make sense either, because this is telling me that eventually the temperature of this bun coming out of the oven is going to level off at a temperature of 0 degrees. Oh, Celsius, 0 degrees Celsius. So it'll turn into a block of ice. All right. So just by being out in a room. So something else to consider, maybe there's a lurking variable. Maybe it's not out in a room. So it's taken out of the oven. Maybe they neglected to tell us that it's being taken out of the oven and put into a freezer. All right? I mean, I freeze bread before it hits the expiration date. So bagels, Jersey bagels, Scarsdale bagels. Scarsdale bagels, the best bagels in the area, I think. I've sampled the bagels, all the bagels I could find. The closest I can get to Jersey bagels is Scarsdale bagels. So, word to the wise. A bagel oven over here is all right. They're reasonably priced, but they're not Scarsdale bagels. Right. So for rounding, you click on the dots in the input field, any one of them, and then press the settings in the upper right-hand corner, and you can establish the rounding. Because you look at these and you say, well, are these the exact values? Maybe you want a little bit more precision. So you hit settings, and then hit settings again for some reason, and then it'll give you the options to change your rounding. And you could go nuts with it if you want, but statistically 3 significant digits ends up being good enough. And you can see it'll manipulate all of your values, all the computations, so that they're rounded to 3 significant digits. All right, so what we were talking about before with probability, it's not so much of a concern related to the rounding, because the computer is going to take care of that for us. All right, if you remember from algebra courses, the concept of evaluating a function, and also from us, it was the idea of making predictions. It was plugging in a value for x and solving. You might remember that being fairly complicated on the calculator. All right, here it is no problem at all. All right, if I want to plug a number in for x into my g function, I want to work with g because I want to work with the one that's most precise. If I want to find the y that goes along with x, all I have to do is type in g of, in this case they're asking me to find g of 10. So I type in g of 10. And it'll spit out the value. All right? This allows me to make reasonable predictions after a period of time. Right? So the bun came out of the oven. It was allowed to cool. This tells me what the temperature is going to be after 10 minutes. All right? But it tells me instantaneously. All right? I could also figure out how long it'll take to get to a certain temperature. All right? I have activities that I do at the high school related to coffee, right? Because I have coffee, Ilio's Pizza, and Hot Pockets. Because I have burned the roof of my mouth on the Ilio's Pizza and the Hot Pockets. I have burned my tongue on the coffee. All right? But bottom line is I burned something on every one of them. So the question becomes, well, when's a safe amount of time to allow these things to rest before you can, dive into it, especially the Hot Pocket. I mean, because that's a variable in and of itself. So what we do is something along these lines: is we nuke the Hot Pocket, and we use a temperature probe and collect the data for a period of 5 to 10 minutes. And then we use GeoGebra to come up with a function model. But then just by typing in something like this is the next step in the process, end solve. You just tell it what the equation is. In this case, I want g of x to equal 60. It'll solve the equation for when the y value is equal to 60. So 60 degrees, in this case Celsius, right? Honestly, I'm not as familiar with the Celsius scale as I am Fahrenheit. So in the context of Fahrenheit, I would say, okay, I'm not burning my tongue on that. In the context of Celsius, that sounds extreme. That sounds like I'm going to probably roast myself alive. Because I'm pretty sure like 30 to 35 degrees is like around 100 degrees Fahrenheit. Yeah, something like that. So 60 degrees. So the scaling on this has got to be way off, because this thing is, well, it is a bun, I guess. Well, anyway, it's going to be pretty hot, even after 6-7 minutes. All right. So I get from this the idea that the temperature is going to be 60 degrees after about roughly 7 minutes, 60 degrees Celsius. So still too hot to consume, I would think. But practically speaking, if you took if you were warming up bread in the oven, like you just got some dinner rolls or something like that, and then you let them cool for 7 minutes, they should not be so hot that they're going to burn the inside of your mouth, right? So there's definitely something iffy about this data, but I don't think we get that just by looking at these numbers. The numbers seem fine, but it isn't until you dive into it statistically that you start making sense of it. All right. So then the next part of it involves you just typing in more data. All right. So this part I don't need to actually walk you through, because it's it's really pretty self-explanatory. So let me just talk you through it. You're going to type the data in, coordinates 1, 38, 2, 41.6, etc. You're going to get these set of coordinates, and then you're going to do a fit sign, all right? And then that's going to create that graph. So sine function, like a trigonometric function. Now, you think, well, trigonometry and statistics, why the hell would we do that? Well, things happen in cycles in the real world, don't they? Temperatures, for example, like wave heights. When you talk about, that you go to the beach, when you talk about high tide, low tide, it happens in cycles, right? Living organisms, there's many cyclical patterns that happen with living organisms. So definitely something that is applicable in the real world. So, but the good thing is you're really just typing in values here, and what we're looking for are extremes when it comes to these. All right, so you just type in the function extremum, and then this command, and what it's going to do is it's going to tell you, because this is talking about temperatures in Central Park over the period of a calendar year. And so it's going to give us a sense of what the high temperature and the low temperature would be based on data recognition. So that's what I was talking about before when I was saying that part of probability is just estimation and pattern recognition. This is the beginnings of stuff like that. All right. And then the last component is going to be you finding a data set online that could be modeled using a polynomial exponential assigned regression. So basically, just look at my examples. We have a bun coming out of the oven. We have temperatures in Central Park. Find a data set that you can create your own GeoGebra graph with, and then find maximum and minimum values for those using the extremum function. All right. So it should be pretty easy. The one thing is that I don't want you, when you research your data, I don't want you pulling it from textbooks or other word problems or anything like that, because that's not authentic. I want it to be like an actual an attempt to discover something that's happening in the real world. All right. You could, and I'll even amend this to say you could actually collect your own data if you want, like from your day to day. You know, I've had people, collect data related to their commute times, and they're comparing what time they leave to go to work every morning and how long it takes to get to work, right? Because for me, if I don't leave at 7:15 precisely, I'm getting to work late. But like depending on how many minutes after 7:15, like if I'm 1 minute after 7:15, I'm 5 minutes late. If I'm 5 minutes after 7:15, it's all over. I'm like 20 minutes late, right? So it could be something along those lines, right? But try to come up with something that's unique to you, right? But the one last thing I needed to show you is how to actually save this, all right? So, because one thing that can be very frustrating is to go through all of this. I mean, you do all this work and then you lose it all because you didn't save it properly. So the 3 lines gives you an option to save. So do that immediately. So call it whatever you want, Tech A. Regression. Have it on shared and then save. All right. Then once you do that, you're gonna click on share. So same menu, the same menu that you used to find save. Click on share. It generally asks you to save a second time, but in this case it didn't. Copy that link, and then you go into the that Google Doc that we created before. All right, so I'll just call that up again. Lovely. So call that up again. So open your Google Doc and just paste that link in there. All right, so this way, when I open that, so I'll just kill this real quick. So when I open this, it brings me right to the GeoGebra file. All right. So that's how you save your work. So when all is said and done for this one, you should have a link for the bun in the oven, a link for the Central Park temperatures, and then a link for your own collected data. All right. And again, that data, it should be something authentic, but it doesn't have to be anything too crazy. All right, all you're doing is just collecting information. All right, something that I do, it's not necessarily apples to apples when it comes to this, but every morning I'm in the car that I'm experiencing pain of some kind, like because I'm always like aware of that. I'll just consider what the barometric pressure was that day because I think there's a relationship. And so one thing that you could do is think about something that might apply to you. So if I were to say, for example, eat dinner at 6 p.m. versus 7 p.m., maybe I take my blood pressure after 6 p.m. versus after 7 p.m. and see if there's a difference. All right, I ask Siri to tell me what the barometric pressure is, but only on days that I'm experiencing pain. So it's kind of skewed because I don't have the information on days that I'm not experiencing pain because I just don't think of it. All right, but you could do things like that, time of day versus blood pressure, right? Yeah, I mean, you could just get creative with it. You could think of a bunch of different options. That's assuming that you want to collect your own data. If you don't, then you could go online. I just recommend that when you have a topic of interest, when you do a Google search, include the word data set. That it makes a world of difference. All right. And so with that being said, that's where I'm going to leave it for today because I can barely function at this point. I'm done physically. I gave everything I have.